Okay, so we are on recording. My screen. So I can still be heard. Okay, hi everyone. So I think we're a lot in this meeting already, and our speaker is here. So let us start. I see that there are some people that want to join, but first thing first. Okay, so let me share my screen. Um, Okay. Hi everyone. Good evening, good afternoon, good morning, wherever you are. You're very welcome to our webinar this evening. My name is Mosumola Olabeno, and I'll be your moderator for today. Um, I welcome everyone for bringing out the time to learn wherever you are. So we are testers quarters. We are the most active software testing community in Africa, and we are focused on empowering, aspiring, and practicing product quality engineers with resources, support, and mentorship that is required to them to succeed in their career. So let's move on to our programs. We have the TQ Office Hour that happens every Wednesday. In this place, we have where everyone are working either in the office or from home come together to talk about any problem they have in the office. So it is more about bringing more ideas, bringing more um, um, tools that you know about than you think people don't know anything about. And it is more about being insightful and asking questions during that hour so people can answer and bring up a suggestion. So on Friday, we have the Friday webinar, which is one of it that we have now. And we also have the the fireside that happens every first Saturday of the month. We have town hall meeting, which happens every last Friday of the month. We have the local community um, quarterly hangout. We just finished NSTW, that is Nigeria Software Testing Week, where all software testers in Nigeria came together, not only to connect, but to learn more. We have the scholarship bootcamp, and the scholarship bootcamp, we recently finished the cohort 2, and I was part of it. Surprisingly, I know some of you might not know me. I'm actually new here. I'm the new community leader, and I took over from Faith. I learned a lot from her. We also have mentorship whereby you learn from people, from professionals, and every single expert in the community. We have a now gathering. As I said, NST is there. We have the tester on. We have IG, LinkedIn, Twitter. So I'm going to be dropping them on this call while we are on this call. So please, I will tell us to follow so that we can be able to an active community. So we have the fun comedy and movie night. So there are sometimes in the month that we pick one day and we just watch movie for that day. We have the test marshal guys, and let's move to the next one. So we would like to welcome the new members. The new members are welcome because I know you might not know this community, and there are some people that might have heard about our community before, but they're just joining. Welcome, you're so welcome. We really appreciate that you're here. Now let's go to our speaker. We have the beautiful, Savi Grover. Savi Grover is a senior QA automation engineer with extensive expertise in software testing, automation framework, and quality assurance strategies. With professional experience at Ford Motor Company and across multiple domains, including media, content management, autonomous vehicle system, payment and subscription platforms, billing and secret risk models, credit background verification, and e-commerce. Savvy has established a strong track record of driving end-to-end quality assurance Beyond industry work, Savvy is an active researcher and thought leader in the field of software testing. Savvy is also a conference speaker and keynote presenter, creating structured talks, technical slide decks, and demonstrations on productivity in agile organization, AI-driven testing methodologies, and automation strategies for evolving software systems. So you see why we brought her in. She's not only beautiful, but she's a very great, intelligent woman. So I would like to give it up to her. Please let us appreciate her as she come up to speak to us. I mean, it is not, I don't know, but it is a great honor to have you here, ma'am. So can you hear me, ma'am?
Thank you so much,
Yeah.
Masood Mala, for
So you
introducing.
can share your screen.
Yes, 1 second. I hope everybody is able to see and hear me properly.
Yes, we can.
Thank you so much.
Yes, sure, we can.
Thank you for conducting this session today. My name is Savi Grover. I'm currently a product focused quality engineer profession with 10 years of experience driving digital product quality, adoption, lifecycle, execution across different domains, as Mohsen Mullah described. And I'm currently working at a US media company driving intelligent solutions, customer needs, and market data analytics, and involving software quality assurance measures. So today's I think somebody should be on mute. It's a little bit. Okay. Yeah, we are good. So today's session is going to be using some of the quality measures to test AI ML applications. And we will start with how AI ML applications are different from our traditional SDLC lifecycle projects. So in a traditional SDLC processes, we have different stages, like it starts with requirement gathering. The second stage is design analysis. The third is starting with development and code. And it then switches to testing phase where we carry out all the testing procedures, finding out dissimilarities between what are the requirements, what could be the bugs, what could be the failures which the system can experience. And the few other stages could be the deployment, where our application environment is deployed onto the production servers, where users can actually experience and get to interact with our application. And then it's constant operation and maintenance. So this is a traditional software development lifecycle where these stages, our application development is divided into these common stages. But how is it different from our AI development lifecycle stages? Uh, After the requirement analysis, first we analyze what is the problem statement, what are we intending to build the system for. We have to then focus on data collection and preparation. So this is much more of a static requirement where the static requirements are gathered. The developers and designers have to club in and pitch in their ideas together, and then they find out the ideas about how to code it. But in AI ML applications, the focus is more on data collection and model development. So first of all, the data is collected, it's prepared, it is filtered out, more of cleansing routine pipelines are applied. And after that, we focus on more on model selection and training. That means what is the agenda of the model? Out of this data, which features we will be using in developing our data model. And after model development, we evaluate the purpose of this application, that if the AI ML application was, suppose, a chatbot, a conversational chatbot. So it's a Gen AI model. The purpose or the output of the model has to be generating text, generating images, giving us ideas, generating videos, and mainly focusing on the context of questions which users are asking. So the model evaluation and validation comes later in the phase, or testing here comes later in the phase after all the data preparations and transformations are done. So this is the main difference between a traditional SDLC and a AI/ML workflow. And when we are finally confirmed with the model is performing well, we have to deploy it in and integrate it with the existing systems and keep monitoring it, maintaining it, and controlling the environment variables. So this is the main difference, and that's why we have a need of employing more additional QA quality measures just to keep all these parameters in check. So the challenge which we face in AI/ML application is we do not have a traditional QA methodology applied here. Why? Because the current practices, they focus more on the pre-deployment settings validation. They lack any systematic approach for real-time quality assurance measures. And in the static applications, we do not face the problem of data and concept drift. That means our applications are static test cases. They either fail or they pass. We have a test result in just two cases, 0 or 1. Either they fail, either they pass, and that's how we validate. But that's not how Gen AI applications behave. They do not capture the evolving nature of data distributions, model behavior in production, leading to performance degradation. Okay. Then model testing in AI/ML systems, the predicted results are formed by model training. So that means whatever the model we have put, whatever the data model training and testing have been put, all the output results will be predicted by it. So we have to compare either they are perfectly matching with the expected results or not. So everything depends on model training. It depends on model testing. The practices are required continuously needed because we also train our model continuously. So if we are training our model, it is introducing changes in that model, in the ML algorithm also. And because of this rapid experimentation, the quality becomes more of a challenge to conduct. And because of accumulated risk, because there is a chance that systems are exposed to the concept drift, they are exposed to data drift. The output could be accumulated based on biases. Maybe the model training is not perfect. The data which we used for training was not properly cleaned, and it introduced fairness issues and introduced biases in the model. And there are continuous performance degradation over time without systematic detection. So why we need these additional measures is because of these reasons, because of data drift, because of non-static fail and pass results, because of continuous model training and experimentation. So moving on, what could be a realistic architecture for this audit-ready and resilient AI deployments? So this could employ from starting with the data stream. So our input, as we saw in the workflow diagram, in the AI/ML workflow diagram, our input always starts from data preparation, that is data stream. So the first architectural system which could be in place is, first of all, data quality validation. We have to map whatever the fields are incoming in the data through a schema validation model. We have to design some distribution checks to see if the data coming does not have biases. For example, it is trained on just one social group, or it is just talking about one particular group of a population, and it is not a generic model to be applied on all the cases. And we also need to find out the anomaly into that data. So after this data has been properly cleaned, uh, the pipelines are in place, the incoming pipelines are in place, we can at the same time prepare for our model training and even making our dynamic test oracles, which is basically our test suites. So those test suites will be doing some proxy metrics. They will be analyzing the scores of the model output, the similarity scores. There is some weak supervision. So all these kinds of evaluation metrics, which could depend on system to system. It could depend on application to application. Sometimes people don't need these. Sometimes they employ it in a limited way. And after the model training has been done, we analyze how much drift is there in the model. That means how much the data is not aligned with our requirements, which we set at the beginning of the application. And when both of these are compared well, when we analyze the degree of the drift, when we have test suits and checks in place, we make a automated alerting and feedback loop system where we can identify, okay, we had a test case, we had an output predicted by the system, which is not going with our input, or which is not going with our intended result. So we provide a feedback in the system, we alert the system that the training has been not working well. So we have to retrain the model and find out what could be the root cause analysis of that errors, why the output generated by GenAI chatbot didn't go with what we really asked for. And this could also be consisting of some maintenance control schedules, which we have. We analyze the observability logs and performance monitoring. So all those alert systems, that could be by our Slack bot, which in companies we use Slack chats. It could be a human who is checking. So it could be a human in feedback loop. So all of these elements and all of these components we will drill down into each one of those. So coming on to data quality validations, what are the key aspects we have to keep in mind? First of all, we have to see if there is a data leakage or data loss at any point in the incoming data. Or we need to find out, is there a place where the incoming data is getting corrupted? Maybe some fields are getting removed. Maybe some fields are getting changed. The values of the fields are getting changed. So this is basically our data check, data cleaning procedure, which we need to employ. Sometimes we have a lot of null values. Sometimes we have a lot of empty values, and we need to assume, okay, if this value is empty, can we replace this value? Or maybe this proper column is not what we need in our model training. You don't need users' payment information to train to find a model to how to get their behavioral training by a model. So there are some aspects of the features which you can completely leave, so that there is less overhead on the model. There is less computation you need to do out of, if a system is having, suppose, 100 columns or 100 fields, there could be just 10 which they could use to make a perfectly accurate model to have accurate results. Then we employ data validation and testing and cleaning pipelines. So all these pipelines are doing these procedures for data cleaning, and after this cleaning method only we could use that data in training and testing purposes. If we are using the raw data for training and testing purposes, it will obviously introduce biases, unfair results, a lot of junk data which will be produced our model, and we don't want that. Then coming on to model stability and performance validation. So the biggest challenge which right now we have regarding the model is ML or DL model is the black box nature of this model. We don't know how the machine learning model performs. We don't know how it is made. We don't know what kind of algorithms were used to program it. These are all the black boxiness nature of we want to test it, but we do not know how it functions. we are just aware of the input data, but this black boxiness of the machine learning models is basically one of the major challenge which QAs face while they have to test the model stability and performance validation. So to solve this, or maybe to have it a little bit easier on the QAs, we introduce the concept called explainability. Explainability means, why did the model decide on a certain prediction? So we explain them what could be the nature of the model is, how it's programmed, not in depth because that's the work of developers, but at least to some extent, so that QA and quality people are aware that how this model was made, how it was programmed, what could be the algorithm which was used to program it, what was the intention of using that algorithm, why not some certain algorithm and why not other. Certain parameters could be explained, and we tell this as a concept called explainability. If models are explainable to QAs, that means they can find out easier, like they can find out bugs easier, they can find out fixings, like things to fix very early in the process, and it will do much less damage in the overall flow. And along with explainability, we have to make sure that these models are visualizing models. That means anyone can see what are the impact of data on it. If you provide one kind of data on the model, suppose image, how the model behaves. If you provide a text data, how the model behaves. So this could be some visualizing models. They should be able to show you how they uh, uh, plot input and output results in the form of charts, in the form of bar graphs, in the form of histograms, so that you can get to know the relationships between different features used. And at the same time, they should be transparent. That means what the model actually is learning. If it's predicting something, that means it's learning something from the input data. So a QA should be able to answer these, and then he should be able to perform the model stability operations and QA over these operations. And the last thing is feature analysis. Feature analysis means, what are the columns? What is the type of data used? If we are talking about users, are we using their name, their age, their gender, their nationality? What kind of parameters are applied onto the specific user population? So this is called as feature analysis, where QAs are also aware that out of all the features, we just used a couple of them. Why we use them? Because we want the model to work in a certain way. So this is the base of model stability and model validation. So moving on to the explainability and interpretability of the ML models. So for tasks requiring high transparency, we need to opt for simpler models. So this can be, or can maybe, or may not be directly imposed by a QA, because this is much of all our dev decisions or deployment related decisions, or you can say like highly specific tech decisions, which the QA are like not having influence on, but they can know about these things. So if we are opting for simpler models like decision trees or linear regression or classification, and for complex models like neural networks, we have to integrate certain explainability tools also. So for explainability purpose, we have certain external algorithms and tools in place. For example, SHARP, which is sharply additive explanations, or LIME, which is local interpretable model agnostic explanation to understand feature importance and decision pathway, that how model performs, why certain features were decided to predict the output of the model. Then the second aspect of testing the model is adversarial testing. That means we have to impose certain opposite nature of data to test the model performance. So we generate adverse inputs to test the model robustness. We uncover some vulnerabilities they are facing. For instance, slightly perverting image input to a computer vision model can reveal if it's misclassifies an object. For example, if you have a computer vision model and you are training that model on the images of birds, and it is trained on, like, suppose 10,000 images of birds, and it knows what kind of bird looks like how. So if you type hummingbird, it will output you the image of a hummingbird. But if you train it, you have to test it. So you have to provide a adversarial test input. So maybe provide a picture of tiger and see how it behaves. Does it qualify as a misclassification object? Does it say null pointer? How does the model behave in such kind of adversarial testing inputs? So this is one kind of testing which we can apply on the model. And then there are some sensitivity analysis predictions. For example, how sensitive the model is to changes in the input features, ensuring stability and reliability. So in this case, also we change up to a certain degree of input into their test data so that we can get to know how the model will behave. Sometimes the model completely hallucinates. It provides false outputs. They are unstable outputs. They no longer go with what we are looking for. And that's why we need to check these params. Are they in place or not? And there are certain other quality measures for model accuracy as well. For example, the first type here is output accuracy. That means we have to check the accuracy of the results. If you ask a ChatGPT model about, for example, provide me the purpose of agile in product management, or what is the purpose of agile in software development lifecycle. So it should give you all the results you are expected to see. It should not give you the results something which is related to waterfall model, right? Because agile and waterfall are not the same thing. So we have to see how accurate the results which are predicted, how accurate the text generated by LLM regarding the asked set of questions or input. ML model operates according to its intended purpose and it delivers meaningful output to you. So this is also called as functional testing. In our traditional SDLC, we call it functional testing, whereas in AI ML workflow, we call this output accuracy testing, or sometimes we also called it as context testing, because we need to see what is the context of the results the Gen AI is reproducing. So style transfer testing is another type where we check the model stability to adjust the tone or style of the output. Maybe our questions could be very harsh. Maybe our questions could be very expressive. Maybe we ask a question in a sarcastic way. So we have to change our style of asking the questions to Gen AI, and then we need to see how it behaves. So depending on the user input or context, for example, a text generation model could be asked to write a formal email and then a casual message on the topic. So you need to see how it designs a formal email and how it writes a casual text messages. Both are different styles of text. So the responses should differ in tone, they should differ in formality, their word choices they use, the addressing of the other people they are using while remaining coherent. They should also retain the meaning of the semantic meaning of what they are trying to convey. Then relevance testing and fantasy claims testing. So we don't want our model to reply in a unrelevant way, right? If we are asking about agile, it should answer just in the context of agile. So this testing makes sure that model remains relevant to the questions, okay, or predictions. It does not fake any kind of answers. It does not make irrelevant claims beyond known facts. For example, if you are asking a health related question to AI, can drinking tea cure cancer? And making sure it doesn't respond with an unscientific and fantastic claim like, yes, tea is miracle cure for all the diseases, because it's not. So we don't want any hallucinating answers. We don't want any extra fantasy claims. We don't want any irrelevant answers. So these are some of the testing types which could be applied on Gen AI models. And then what is the intent of the model? So in all the cases, in all the cross questioning, cross examination, we want to maintain that the model's intent is known. That means the test whether the model can correctly interpret the intent behind the user input, okay, including recognizing sarcasm and humor. These are some of the complex features of a chatbot or a complex features of any Gen AI, like AI system. But at some point of time, when we have things developed well in place, we want to make sure that their intent is clear. So this is why this kind of testing is called as intent recognition by model. Then we need to make sure content management testing. That means this evaluates models' ability to retain context over multiple interactions. Suppose you have interacted today with a chatbot. After a few days, you are back with another query related to the same topic. The chatbot or the model need to be coherent. So a series of conversation with a agentic AI or a chatbot should be able to retain the answers with the same chain of thought. It should not deviate you from the topic, or it should not deviate from the replies it gives around the topic. Then we have user action prompt with choices. So the same context could be maintained if you provide maybe multiple choice in your questions. So this checks if the model can easily interpret those choices, can provide actionable options to response. You can also ask the model that, can you provide me some bullet points as to how I should define agile, or any of the input query which we want to put in. Then one kind of testing here is called as zero-shot testing. That means we have to apply an unseen prompt on that model. The prompt or the input which was never used in training, it was not used in test data, and then we need to see how the model behaves to this unseen kind of a prompt. So in regular ML models, we also call this as cross-validation testing. And in case of Gen AI conversational bots, we call this as unseen prompt testing or zero-shot testing. And then we lastly need to check like repeatability and invariance testing, which also same applies on LLM model testing. Repeatability here means in whatever number of ways you are asking about a context, the AI should be able to answer it properly, still relevant to the topic. And invariance testing here means if you introduce some new queries in the some new invariable queries in your input, how the AI behaves and answers you according to the relevant questions also. Then we come to what is drift detection. So in very simple terms, drift is something which gradually degrades the performance of the model. And why this drift occurs, there could be three main types of reasons. Either the data or the input data which we provide to the systems are changing continuously, or maybe they are changing very slowly. Sometimes drift is introduced in the system and you get to know it after a lot of time has passed. And that's when you realize, okay, that was not the intention that was not the intention of the model, but the drift is there in the input data, and that is why it is behaving, it is giving answers out of some context. And sometimes it could be concept drift. That means the features which we have used, the input, or you can say the data mappings which we have used, their relationships have changed with time. Because as the application evolves, the features are evolved, new features are added, older features are sometimes eliminated. So we need to keep these two things in check so that we can make sure there is no drift or slow drift degradation into our model. And the third kind of drift is label drift, where we change the name of the input fields. Sometimes we change the address to some other name. We just change the headings of the input fields, and later on we are confused. Okay, the older headings were used in the system to address it, but the system no longer knows them now. So this is called as drift. So for drift detection in ML models refers to the process of identifying when the statistical properties of the data used for training a model differ significantly from the data of the model, and it encounters in a production environment. So this discrepancy is known as drift, and it can lead to degradation in the model performance and accuracy over time. It cannot be drastically pointed out that, okay, today drift happened. It happens over time that the data, incoming data, is sometimes degrading our model. So what are the key detection methods? So we can use certain graphical distributions to analyze the drift. There are certain external tools also, which are like commercial tools we can employ with our APIs, with our service logs, and get to know and monitor these performance metrics. Then one of the other component of our AI/ML workflow was alerting and feedback loops for operational excellence. So basically, this phenomena comes into picture when we identify a drift into the system, and on real time our system is concerned and gives a alerting or alarming message to us that the data drift has been happened, that and now you have to improve your model. And there could be many other parameters also. I am just using one example here, that how threshold score can be used to analyze the data drift here. So whenever drift score reaches a deviation threshold, we employ a feedback loop. This feedback loop could be in the form of any message, a Slack message, a log error, email linked by the system for further testing and reporting the bug. And here we are taking the example of, for example, composite anomaly risk index. So anomaly risk here means the measure of drift which has happened into the system, and it could be put in by the formula where W1, W2, W3, and 4 are certain weights which are used by the data scientists. And we have some drift score, we have accuracy drop score, how our accuracy has been impacted in the system, and what is the drop of the accuracy, what is the bias disparity. That means if we are observing biased outputs, so we also calculate the bias disparity here, and we also have a stability variance. So all these params are determined by data scientists in the team, data developers in the team, because they are in the constant touch of data pipelines. They know when and how we saw the accuracy dropped and bias parity, and that's why they could evaluate the scores. And for example, if we have a score more than 0.7, so that means we are at a high risk. So we can alert our system as soon as this score reaches to 0.7 or more. We have to stop the testing, and the model has to again retrain, and there could be other processes, but not testing. We have to stop testing at this place because we already know that we are in a high risk situation. If we have a 0.5 to 0.7, we could say that still a human QA review is needed, but we are in the level of moderate risk. And if we have the score which is very less, like less than 0.5, that means no action is needed. The model is performing as it was needed to. We are getting proper outputs as we wanted. So what kind of triggers this early feedback system can have? For example, we could generate alerts via Slack, email, other tools, PagerDuty. We can have a push event into the message queue. If we are using data streaming applications like Kafka, we could have a log message report this error. We can log result directly into our QA dashboards, maybe directly log a ticket in the Jira. And then we have data log queries where we can see a graphical representation of a higher threshold marked by certain red color, and we know that there is a problem in our model. And how the feedback loop could be designed is they are a process where model outputs are evaluated, used to refine the model iteratively. They evolve, feeding the model prediction back into the system to learn both current and incorrect predictions. What is the purpose of the loop is to, again, identify weaknesses in the model, adapt to the changing data distribution, improve performance over time. Example, model outputs, source of learning, using the model prediction as new training data to refine its understanding. So if our data is evolving over time, we can retrain our model and again put it under control. Similarly, we have user feedback. Sometimes user complains that they are talking with an external chatbot which is integrated on your website, but it's not giving proper answers. So that means we have user feedback integration into the system, that incorporating user interaction, we can see over their chats, we can see what kind of chats has been done, we can see why and what are the outputs which are given by the chatbot and how they are not accurate. So these are some of the areas where we can employ a feedback loop. And we can also have an automated retraining pipeline where, again, we have new data and we can retrain our models on new and updated data, as it will also reduce the drift into the system. Then how can we see there could be some visualization dashboard channels? For example, we have live QA health score. We can have drift trend lines. So all these dashboarding panel are employed by data scientists. We have data analytics team who does that. They try to see the trigger logs on retraining and action history, and there could be real-time Slack integrated alert feed system. And what happens when we retrain our workflow? So pulling the latest data batch from the data lake. So data lake is one of the system where all the clean data is kept so that it is ready for future model trainings. So we need to pull the latest batch, validate the quality measures, check all the schema, null checks, check how integratable the data is, retrain our model using that existing pipeline with the adjusted sampling of fairness constraints. We also need to make sure our threshold values remain the same into the system, or maybe adjust them accordingly. Evaluate the retrained model on the recent streaming data, deploy this retrained model once we know that this model is behaving well after model training and stability testing, and then re-enable the monitoring loop. So this is the same flow, but in an iterative way, we employ retraining workflow. And lastly, there could be a human in loop feedback. For example, instead of seeing all the constant results given by a chatbot, there could be a customer care representative complaining or telling us that they are not getting proper responses from the chatbots. So this is a manual analysis way of finding out how the output results should behave and how they interfere in the retraining and data drift oval loops. Lastly, we have a concept called ethical and responsible fair machine learning testing. So these are some of the testing measures which ideally a QA should take. They weigh a little less from the other methods, but these are the key principles that we need to make sure the Gen AI and AI models are behaving properly in terms of they are not giving any toxic results, they are not giving any false hallucinated results, and they are also maintaining the guides for data protection, safety testing, intellectual property, because all of these are compliance related testing. So we need to make sure that there is either a compliance team, or if we don't have a compliance team, a QA needs to make sure that they are maintaining these testing measures. So first of them could be, for example, transparency, that all the AI operations should be understandable, explainable. There should be accountability, that developers and organizations should be responsible for AI outcomes. The results should be fair to all the groups, to all the kind of users it employs, it plays with. AI should not discriminate or perpetuate any biases into the system. They should maintain user privacy. For example, if a user is again having a conversation with a chatbot and pass on his email, so we need to make sure that that chatbot is not leaking that email, or if there is a number provided by the user, it does not go out of the system. There is proper masking of credit card data. The credit card data should not be like in wrong hands. So all of this kind of privacy safety measures should be checked by a quality team. And beneficence here means AI should contribute wisely to the society. So these are some certain safety related measures. And lastly, there are some foundational checking of this AI ethics, that it should not harm, the safety security should be maintained, the privacy and data protection should be done, transparency and explainability as we discussed, fairness into the society, human oversight. That means it should be able to assist a human into doing task. It should not like take the place of human. So if we have a manual QA checking all these loops and already reporting a bug, we should not oversight it saying oh, if it's not predicted by the feedback loop, we still should not ignore the human intelligence and human intent into it. And lastly, it should be sustainable. Although sustainability comes very last in the stage, but it's needed the most. The computation cost of these models is a lot. It is harming the environment. We are using a lot of chips, a lot of computation power and processes. But we need to make sure that if our data is cleaned properly, if we are using limited number of features in the start, it will still harm a little less. It will still cost us a little lower energy and lower computation cost. So this was all about the session today. Thank you so much for your patience and for the session.
Wow, wow, wow. That was so great. Ah, I can't get over it though. Please let's appreciate her. Let's appreciate her. Wow, thank you so much, ma'am. Thank you so very much, ma'am. So I'll be can I ask questions if you don't mind, ma'am?
Yes.
Okay. So I would like to ask how do you test for edge cases where the model might completely fail or produce harmful results?
Can you repeat that question?
Okay, so let me repeat that. I said, how do you test for edge cases where the model might completely fail or produce harmful results?
So, for using the or producing the edge cases of the AI, you have to first focus on the explainability measures taken by the team for the AI. And I'm sure if you are aware how the model behaves, what are the certain parameters it is focusing on, you can find out the boundary value analysis, the input class testing. All of these edge cases could be reproduced, but firstly, we have to get to know what is the intent of the model to perform testing. And you can also take the help of external teams who are trying to use that model, how they will be functioning with the model. If you have external users, get to know what purpose they want to fulfill after this whole deployment processes are done, and then figure out, capture a traceability matrix, maybe capture a matrix so that you can record what kind of edge cases could be tested with the AI.
Okay, thank you so much. So I want to ask one more question. For QA testers transitioning into AI ML testing, what core skills should we focus on building?
Focus on feature engineering. That's the most important. Focus on algorithms which are used by the QA team. If you still want to remain in the QA line, I would still focus on more on what kind of feature selection, feature engineering was done by the team, uh, how we map the different features, input features, how schema validations are done. Schema validation is already in traditional QA also. We do a lot of schema validation where we have a large number of input and we need to make sure they are coming into the system, mapping to our schemas well. So feature engineering, feature selection, schema validation, focus on algorithm. I would say these four steps would benefit you if you are transitioning as a QA in AI system. Any other questions?
Can anyone hear me? So I'm sorry about that. That's network. So do anybody have any question and answer? Any question, sorry. Oh, Jesus. Oh, I'm sorry. I'm so sorry about that. MTN wants to show me shady tonight. No, God will not allow. So we are on question phase. Please, anyone with a question can answer question. Can ask any question, and Miss Savvy would answer. Okay, so I'm seeing a lot of hands. Let me start calling, and you can unmute your mic and ask the question. Olamide Ogunyemi, you can ask the question.
All right, thank you. So my question is, how can someone navigate this area of testing as a beginner?
You are targeting about AI testing or just regular testing
No, AI testing
as a beginner? Okay.
as a beginner.
Hmm.
So I'm actually preparing for an interview, and when I made my research, I saw that their product is around computer vision. So hence my question.
Okay. So first of all, you have to get to know around what are the classification of algorithms which are used in the AI system. There could be linear linear classification. There could be regression models. There could be clustering groups, segmentation algorithms. You don't have to deep dive into their implementation, but at least get to know how they behave, what is the input, how they predict the results, if they form the segment, how they form the segments, what are their applications. For example, if we are talking about segmentation or clustering, we know that they are used by marketing campaigns, they are used by advertising campaigns. If they identify a similar group into the system, group of people or group of user into the system, they will flood their emails with some promotion codes, marketing campaigns. So get to know what are the use cases these algorithms have into their system, get to know how they behave. Then try to get to know what could be the quality measures around this, how you could try to break the system, knowing how the algorithm works, and try to come up with test cases, try to come up with edge cases, try to depict in the interview how you studied around the domain specific questions also. So, and again, feature engineering means the selection of the inputs was done to do the model stability operations, feature selection, know something about how they clean the data. It's not a part of QA, but you should still know what are the strategies they use to clean the data, what programming language usually they integrate with Python, but get to know all these aspects of AI, and then I think that will be beneficial for you.
All right, thank you so much. I really appreciate this.
Okay, so can you guys hear me? Any other question? Any other person? Any other person that wants to ask questions? Now is the best time to ask any question you have to ask. Okay, so since there is no question, let us move to the next agenda, which is stating what we are having tomorrow. Well, before I finish and before I go on, let's appreciate our speaker for today, Savi Grover. Thank you very much, ma. That was so insightful. That was great. I learned a lot. Thank you. They do say when you honor people, that is when you want to honor people, you appreciate them too. That is part of honoring. Please let's continue to honor her. Thank you very much, ma. Thank you for everything. Thank you for tonight. That was really insightful. So let's move to the next agenda. So tomorrow is going to be a great day for us because I'm actually looking forward to this. So apparently, today was great, and I actually look forward to today, and I was like, okay, so what am I going to learn today? I had to like research on AI, and I was like, even if I know ChatGPT already, I was like, let me just research about AI to know what's going on. I'm gonna know. I'm gonna know before I come to this class. And to be honest, I was not disappointed. I was not disappointed. So let's move on to this beautiful woman that is Olubukola Omotayo. This is happening tomorrow by 11 a.m. I mean tomorrow Saturday by 11 a.m. and it is fire chat where we come together as a QA tester to ask questions, and to be honest, you don't want to miss it. I mean, when you have questions about your offices, you have questions about um, um, where you're having problem with when it comes to QA testing, you have questions with interviews and all those things. I mean, you have to like come for tomorrow meeting, and you don't want to miss it. So let's move to the next. Oh yeah. So this is the end of this session. I'd like to say thank you very much for coming here. Not by only showing up, it is also by learning. So thank you very much. Thank you all for showing up. I look forward to hosting you guys and moderating you guys tomorrow again. Thank you so much. So we can unmute our mic and say our goodbye. And at the same time, we should thank Savi Grover as we are doing that. Thank you, Savi Grover. Thank you, everyone. I wish you a very nice sleep and wonderful sleep. Thank you so much. So good night, everyone.